Morning, folks. We're going to get started. So this is Brian McNamee here from Krisolis, and you're very welcome to our webinar this morning on conversational interfaces. I'm delighted that today we have a really strong panel of Shane Lynn from EdgeTier, Frank Lynam from Woebot Labs, Robert Ross from TU Dublin, and myself, who's going to be the moderator today. We're going to have a nice discussion about conversational interfaces, what they are, what people do with them, and I guess the interesting things involved in trying to build and deploy conversational interfaces. Pretty much this is going to be our schedule, so we're going to have a little discussion about that for the next 15 or 20 minutes. Then Robert is going to give us a little taster of the Masters Series session that he's going to run next month. He's going to go through very quick overview of how to build a conversational interface, and then we'll come back for 15 minutes or so of Q&A at the end. We'd be delighted if you could get involved through asking us some questions. If you look in the Zoom interface, you'll see the easiest way is through the Q&A panel there. You can type in a question just to notice all the attendees at the webinar will be able to see those questions. If you do have a message for us that you don't want everybody else to see, so for example, if the signal isn't coming through properly, if you open up the chat box, you can just speak specifically to ourselves here. Aoife from Krisolis is hiding in the background here, and she'll look after any technical issues that anybody has. So feel free to pop in a message there. Or if you do want to grab Aoife's attention, just hit the raise your hand button. And we'd be delighted in that Q&A session. If people do have questions for the panelists, do please feel free to type them in there. I'm going to jump straight into it, and we'll get started with this morning's webinar. So I'm going to turn off the slides for a second. And hopefully everybody can see that, and we'll start to maybe go around and get some introductions from the panel. So we'll start with Shane. Maybe Shane, you'll be able to tell us about yourself and tell us about what you do at EdgeTier.
No problem. Thanks, Brian. So Shane is my name, Shane Lynn. I'm CEO and co-founder of a company called EdgeTier here in Dublin. And at EdgeTier, we work in the area of customer service. So specifically in the use of AI and machine learning to improve the efficiency of customer service agents, and even more specifically in the domain of text-based communications. So we use a lot of the technologies around conversational interfaces, natural language processing, in conjunction with human agents to really improve the quality of customer contact in customer contact centers and the efficiency of the agents delivering that. So we have a number of clients across Ireland, and we're expanding into the UK at the moment. So it's a real topical webinar for myself.
That's brilliant. Thanks a million for that introduction, Shane, and thanks for joining in today. It'll be great to hear as we go through the discussion how you're kind of using those tools to support, I guess, human conversational agents in the background to this. So Frank, we might come to you next. You might tell us about what you do at Woebot Labs.
Sure. So my name is Frank Lynam. I'm the engineering manager here in Dublin in the Woebot Labs Dublin office. So Woebot was founded in 2017 by Alison Darcy. She's an alumnus of UCD, but she went out west to Stanford in California. And while there, she was doing a lot of research into how to make mental health services more accessible. I mean, she was looking at lots of different barriers to entry, like stigma, distance, cost, things like that. And she tried out, as part of her research as a psychologist there, she tried out a lot of different techniques. Some of them digital. And so in 2017, Woebot, which is a chatbot therapist app, came out of that. And it was early on, it was backed by AI Fund, who is led by Andrew Ng, who's a big name in deep learning. And since then, it's been going from strength to strength, really. I mean, it all goes back to that original mission statement of making quality mental health care radically accessible to anyone, anywhere, at any time. And so we use AI in a quite a specific way, which I think we'll get into, and it's kind of a hybrid approach with directional trees. So So yeah, so it's great to be involved in this conversation and to talk to people potentially in academia, which we have deep ties with, about what we're doing, and hopefully get some interest going in what we're doing.
That's great, Frank. Thanks for that. I think it's as an example of a conversational interface with hundreds of thousands of users running 24/7. I think Woebot is brilliant, and it's great to have you to chat about that. And last we come to Robert Ross from TU Dublin. Rob, do you want to tell us about yourself and what you do at TU Dublin?
Sure. Hey, everybody. I'm Robert. So yes, as Brian mentioned, I'm a lecturer in TU Dublin. And more importantly, I've had an interest in conversational AI for probably 15 odd years. I would have originally done my PhD in it, and still extremely active in it. And particularly, I'm very interested in building dialogue where we're interacting with complex systems. So they can start at the end of web systems, interacting with web agents, but all the way down to robots and interactive applications. And I think this was an area that was always challenging to work in, but I think recently it's become very exciting in terms of the number of tools, the number of technologies that deep learning has introduced. And I think that's something I hope we can touch on today.
That's brilliant, Rob. Yeah, and hopefully we'll dive deep into that. What we might do actually, just to get the conversation going, is stick with you, Rob, and talk about, what is a conversational interface. And you sent me this nice picture that I'm going to share on the screen now, all things going well. And I'll pop that up on the screen, and then you might talk about, what is a conversational interface? What's the spectrum of things we're talking about?
Yeah, so I think just setting the scene for any conversation about conversational intelligence, it's useful just to make clear what it is we're talking about. And in fact, we're talking about a lot. But over the years, there have been many different types of systems that you can interact with via language in different ways. And some of these are referred to just as chatbots. And some people use that term in a good way, and some people use it in a bad way. And we have things like interactive voice response systems, which have been popular for many years. And they go into the whole area of integration into mobile phones, where you can have that combination of voice and text and pressing buttons still coming into use. And then you can have really, really complicated systems that have elements of these two things. So a little bit of chat, a little bit of really structured, tree-driven or state machine-driven interaction, but right down into frame-based or what have traditionally been called agent-based systems, where they have a little bit of drive of their own. They're not just listening to what the user said and just giving a strict response to it. They're trying to push the conversation along. So what I thought might be useful, and that's what I've just laid out here, is highlighted what I think two are the most important axes whenever we talk about conversational intelligence and trying to figure out what we need as an organization. One axis, the one that's running up the y-axis there on the left, is just task interest. There are systems developed that are really smart to interact with, and they seem to be very smart in that they're talking to you in a naturalistic way, but they're not actually achieving any goal, any tasks really. So that would be your classic chit-chat type system. Whereas if you go right up the y-axis, you're looking at task machines and abilities that are a lot more task dependent, where you're specifically trying to get information from the user and maybe check it against a database. And of course, in reality, most systems live somewhere along that spectrum on the y-axis. So that's one of the key dimensions I think is worth highlighting. And the other one running along the bottom there is just what I refer to as conversational ability. How much can these systems actually have a meaningful conversation? At one end of the extreme, you have the idea of systems that just listen to an utterance or parse an utterance and they give a response. That's one end of the spectrum. Right down at the other end of the spectrum, you have systems that are driven by knowledge and information we need to get from the user. And they've got very sophisticated rules and probabilistic and machine learning systems going on under the hood driving that. So I think any system we're interested in can be placed somewhere in these sorts of axes, but I'm not even touching here on the issue of whether we're talking about text or speech. I think for today, we're going to talk about text an awful lot, but there's a huge number of different ways in which we can look at these types of technologies.
That's brilliant, Rob. Thanks for that. And I think that puts a nice context on the range of different things that we're talking about. Given that, we might come to you, Frank, to talk about, I guess, in a bit more detail about what you do at Woebot and the kind of conversational interface that the Woebot app uses. So maybe you'd be able to tell us a bit more about how you use those kind of interfaces there.
Sure. Yeah. Well, like as I mentioned before, we use these techniques in quite a targeted way. I mean, at its core, we have our content and our user profiles, and there are kind of two data sets. And basically, our content has been created. That's really our value. That's been created by a team of clinicians who are trained in the particular treatments that we specialize in: CBT, cognitive behavioral therapy, sort of mindfulness-based CBT, and some other therapies. And as I say, that's our USP. So it's really the challenge at a technical level is how do we feed that content out to the user in a way that's sensible. So effectively what we do is we have a large directional tree that the user flows through in quite a predictable way. And I guess that's not what we're talking about today. But at specific points in that route, in that user journey through that tree, the user will be either required or they may, by their own volition, enter free text, which will then decide which route they take next. So at that point, we employ NLP. We run the free text through a series of classifiers, and we get back probabilities about, what we have a series of classifications. So we basically get back, I feel pain today, and that will give us back probabilities based on whether this is an SOS from the user, whether it's about physical pain, and so on and so on. And based on those probabilities, then we can then decide what route then to take within the tree. And then you might be back into, traditional directional tree again until that free text entry pops up again, and we have to make another routing call. So as I say, very targeted and maybe not incredibly advanced, but we're always trying to improve on what we're doing on the deep learning space. And I'm sure we'll talk about that, our plans for the future.
Yeah, that's great. And I guess that keeping that in mind, that given the application domain that you work in, that sort of focus on the task, I guess you could call it, is very important, where that interface is doing a very specific job and can't just have this nice chit chat idea.
Yeah, like exactly. I mean, and as you say, it really does depend on the domain you're working with. What user need are you trying to meet? I mean, with CBT is highly structured. So if you go to see a therapist, they will run you through quite a structured session, and that's why to have like an open domain conversational agent, it's it could be an approach. It's not the approach that we've taken. We've decided to be quite structured about it. And it's not just because, it would be difficult to do the other way. It's that there is actually a real user need. And that's kind of, the big takeaway that I'd like to put across today. It's go back to that user need. These technologies might be, cool and maybe able to do lots of things, but ultimately, if your user doesn't require those things, then there's no point in doing it.
Yeah, I think that's a really good point. Maybe coming to you, Shane. So we've mentioned sort of NLP and deep learning and things a few times. I know at EdgeTier you do a lot of work in that space. Maybe you talk about just a bit more depth about what.
Where we fit in. Yeah, I think Robert's diagram is really interesting there, and I feel that in the customer service domain and that area of customer experience and automation of customer contact centers, I feel that it's funny, the bits in the bottom left, the kind of chit chat, general conversational pieces generate a lot of headlines, but actually kind of lining up with what Frank said, I think the reality of the implementations is that those things are very shiny and are fun to play with, but their actual industrial uses are limited, I think. Like, I think at customer service, for us specifically, things fall into one of two buckets. So there's the completely automated a completely automated interaction with a customer where, you know, a customer gets in touch and no human contact is used to deal with that query. And there's a limited set of things that can be done in that space. And for us, what we see is that when we work a lot with enterprise contact centers. So typically 100+ agents on a contact center floor dealing with thousands of queries per day.
Yeah.
And a lot of the stuff that's really completely automatable is kind of handled, whether it's by a chatbot, and typically small use of chatbots really compared to what the press generates around them. But a lot of them are covered in the application you use to manage your electricity bill or your travel booking. You know, you're already doing the simple stuff like change my date and time, update my address, change my email. All those things that inherently are very good from a chatbot perspective because the answer is always the same to every customer. They're already farmed off a little bit by FAQs, by good self-service portals online, by a good app, by an IVR when you dial in. And when we're looking at enterprise contact centers, what agents are actually doing is much, much more complex. That the things, no one really wants to go through the rigmarole and speak and work through a problem with an agent unless they've got a real problem. And the problems we see are quite complex and they fit into the categories that chatbots cover. So it might be like, change my booking. But when you look into the actual content that you see in the contact center, it's typically quite complex. It's like, I tried to change my booking and something went wrong in the process. And now I got 2 emails and one says I'm going on Tuesday and one says I'm going on Friday and I don't know what the story is. And actually chatbots are very, in our experience, they're very far from automatically parsing that type of content. So what we do is we really focus on bringing the automation as far as possible in answering and proposing the responses to the agent. So giving them all of the tools that they need and all the information pulled from back-end systems to say, here's this customer situation, here's the topic of their conversation, and here's what we think you should say. So we do generate a response, but we continually keep the human in the loop to make sure that the customer's experience is as high a quality as possible. Because I know in, say, a cancellation email where you can detect reliably using machine learning, this person wants to cancel their booking. The response is quite different between, I want to cancel my booking, I don't want to go on holidays, versus I want to cancel my booking, I've caught COVID-19. So you don't want both of those to come back with the automated responses saying, here's 25% off your next booking. You know, to inject a bit of human empathy without building a specific COVID illness detector and flow, you want to keep that human in the loop. And I think there's a spread of companies out there that give a level of importance on that. And some who want to just cut costs as much as possible at the detriment of customer experience will opt for send them the cancellation email. And then there's another side across the other side where you've, you know, typically in companies where you've high value, low contact type rates, where you really want to mind the customer, or maybe they're in a stressful situation, your agent will be there to say, I'm really sorry to hear about that. Let me see what we can do for you on this cancellation as quickly as possible. And that makes a big difference for the customer experience. So we focus on that side of things.
That's really interesting. And do you find the agents who are working in those call centers, are they big? Are they very enthusiastic once they get to see that? I presume there's a threat thing. They say, "Oh, look, here's the technology to knock me out."
Yeah, no, it's funny actually. No, because what we tend to look at is the work that agents are doing before we enter. So we split down the processing of a query into kind of 6-ish tasks. So there's 6 kind of things, and they vary from like reading the initial query. And then like looking up the information, maybe 3 or 4 different systems, find out what that customer is, have they contacted before, what do they want, all that stuff has to be done. Then there's kind of composing a response, and that requires looking up a template, then altering that template. Then they'll customize it a bit, they'll send it, and usually there's a wrap up. Yeah. And when we examine those things, really the only uniquely human pieces there are understanding complex intent from a customer and fine-tuning the response, right? And when you think about your experience with customer service teams as well, what makes a very good customer service experience is innately the human parts. It's the ability of an agent or response to show humor, negotiation, the ability to understand complex requirements, the ability to empathize with your situation. They're the bits that make customer experience good. Yeah. And actually they're the bits that AI is the worst at. Yeah. So we focus on using AI for an automation for the bits it's good at and keeping the human in the loop. And actually the agents then tend to, we get a very good reception because they're like, oh my God, that's brilliant. Because they're just fed up copying and pasting the same thing into 6 windows every day and copying and pasting things back. All those things go away. And it's just, what does this customer want? Is this the right response? I'll edit it a bit. Next customer. And it becomes a very streamlined process.
That's brilliant. That's really interesting. Maybe one other question before we jump into the tech demo. So it's come up there a couple of times of there's a perception of magic out in the world, and I guess high profile things like the Tay chatbot from Microsoft or the Mina one from Google more recently, I guess speak to that a little bit. When you go out talking to people about deploying or developing conversational interfaces, throw this out to all of you, do you come up against that? And is there a little bit of work to be done to drag people back down to reality, or is that nice that there's a lot of enthusiasm for potential here?
I'll start off there with just a little bit of an opinion on it. I'd say there is always a slight misinterpretation in terms of the level of intelligence that can be there. And yes, I'm sure the guys working in industry feel it even more. There's a continuous need to pull people back in. But I would say, maybe this is a controversial statement, that the Alexas of this world have done a great job for us in terms of helping to set people's expectations with what works and what doesn't work. You know, in terms of setting an alarm timer, calling for music to be played, generally all working out very well. Don't try going deep into a conversation. There isn't one to be had. Don't try bad pronunciations. She's not going to be able to understand you. So I have a lot of time for Alexa and what she's done to set expectations at a reasonable level, but maybe that's just my opinion.
Brilliant.
Yeah, I mean, sorry,
Frank, you go.
Go ahead.
Yeah, I mean, on that question of the magic, I mean, it's like I see it from two perspectives. You've got kind of the internals in the company and mainly the board, I guess, their expectations, and then you've got the user expectations, and that's why it's great having Andrew on our board, because I guess he's well aware of the possibilities, you know, so that can kind of manage those expectations. So we can do things in quite a strategic and targeted way, and in a way that we know we're going to get certain results, as opposed to, you know, overreaching the technology. And then on the user front, I mean, like it's one of the great things about working in Woebot, where you'll see transcripts, you'll be looking at transcripts, but of course, sometimes, you know, Woebot will get it wrong, and we'll see things like, you know, users will respond with, you know, I feel you've gone a bit mad today, Woebot. But it's because, like, we put a big store in the kind of the humor element in Woebot, where maybe it sort of, it lowers those expectations a bit, so that, like, we throw in jokes and things, so that when we make mistakes, you know, it's not that we want to make mistakes, but it lessens the blow to the user, who are often, you know, in vulnerable positions. But I guess it's a lot of it is how you present what you're doing. If you're saying, oh, we are, you know, we're going to deliver, you know, this, and you can depend upon it. Well, then maybe, you know, you're just bearing across that you know, you can't deliver upon. So, like, we put, as I say, a lot of store into just the presentation of what we're doing, and maybe it just lessens those expectations a bit.
Yeah, it's really interesting.
Do
you want to add to that?
Yeah, I'd love to. Yeah, so we come across this the entire time. Like, this is in customer service and that area of customer contact centers. Like, the overselling and massive excitement around AI over the last number of years is just, it's mind blowing and false. I think first of all, it is magic already, right? So the fact that we can, like, freely write text into these into algorithms that can then categorize them very accurately into buckets, which is really what a lot of it boils down to, like a text classification piece, and we can do that like at, you know, human level accuracy, is already magic. What we come up against is a lot of people asking, you know, when will the system start to reply for itself, or when will the system learn that the responses should be this way? After seeing agents speaking. And I think they're logical questions. They're reasonable expectations, because people tend to put human characteristics on their machine learning products. So they anthropomorphize those products. So they think that because it's learning, it's continuously learning. The same way as like I have a 1.5-year-old in the next room, and I can see him now counting to 10, and kind of like he misses 6 and 7 every now and again, but he says the numbers and he points at things, and I can see how he will learn more things, and eventually he will drive a car. Whereas people don't see that when you build a machine learning system to classify things into 10 different topics, it won't learn another topic. It won't go any further than that. And even seeing all the text coming through from agents, we have to reason people back and say, well, the system knows statistically what agents say, and it knows what the words are, but it knows no meaning behind those words. So you don't really want it to self-learn, because the quality of that self-learning without direction is absolutely random. If you've terrible agents, you will end up with terrible responses. And that's what we see with the kind of self-learning online, like chatbot that learns from users. They are self-learning, but they have no concept of what they are learning. It's all just statistical representations of what word comes next after the last 4 words.
Yeah.
And that may be meaningless or bad or good. So it's a dangerous path, I think.
Yeah, no, I think they're really interesting, really good points. And I think we'll come back to those. We might jump into, Rob, your tech session here. So for about 10 minutes, you're going to give us a deeper dive on how to build the kind of systems that we're talking about here. So I think we're going to see bits of NLP and bits of deep learning, and then bits of a conversational interface on the end of that. And then
can you see my desktop there?
I can, absolutely. Yeah. So
Excellent.
go ahead.
Okay. So I think in terms of the technologies, what really always has excited and scared me at the same time about conversational interfaces is the pure range of technologies that need to be pulled together to build good examples of conversational interfaces. And, we've spoken about that a little bit over the last few minutes. And what I wanted to do just in these couple of minutes ahead of us is pick out 1 or 2 of the key technologies that are relevant and show where they are used, why we need them. But naturally, I can only sort of highlight a couple of the key entries. Like, we're going nowhere near speech. I'm not going to be able to go into the decision processes that the conversational systems make. But just to sort of, for anybody who's relatively new to this, just to get us aligned and started with, always in terms of your conversational interface, this sort of diagram is pretty classic in showing that there's maybe 4 key components we're dealing with. We're taking that user's input. We need to do a certain amount of pre-processing on it, a certain amount of analysis on it. We then need to decide, figure out what the best approach to understanding meaning is in terms of what the user said. What did they mean? What's our best guess at what they meant? And only when we have that, or we have some estimates of what that might mean, do we come back into the other half of the equation, which is saying, well, what is it we should be doing right now? Should we be checking a database to get answers for the user? Should we be saying something back to them straight away? Should we be sequencing that? And then, of course, the final step is actually producing that output, which for a text-based system can be relatively straightforward, but obviously if we're into speech, it's a little bit more problematic. So I've got a Jupyter notebook here, and I'm going to illustrate some of the core ideas with it. I've pre-run this notebook because some of the steps do take a few seconds, and I didn't want to have them going through one by one in front of us, hanging on, but we're just sort of setting up the notebook there. And what I wanted to mention and talk about was data. Like, I think we've spoken about this a decent bit, that really in these modern systems, we can handcraft a lot, and there's nothing wrong with handcrafting some things to begin with. But as the systems get bigger and bigger, we need data. We need to know what is it that the user says, and if we have access to conversations between the user and agents, I mean human agents, that we have inventories of them or corpora of what's said. So that's what I've just loaded in here for some examples. We have a straightforward corpus here of just things that a user might say to a banking or a finance type demo. Naturally, in any real collection of data, we're going to have lots and lots of different ways in which things are said. And some of which just make sense. Some mightn't even make sense to a human reader going through these. We then also can have what are in a way more valuable in the long run for dialogue systems or conversational agents production, which is where we have that full corpus. Now, the problematic thing is we can usually get access to corpora, particularly if we're working with enterprise partners and they have agents speaking to users all the time. The challenging bit about working with corpora is usually the labeling of them. It is labeling them for different topics, different intents of what the user meant, and an awful lot of time and effort can go into that labeling process. I'll say a little bit about that later, but it's just worth keeping in mind that's a big challenge. Now, so as I've already mentioned, in building a conversational interface, there's really a dual linked set of tasks that we have to perform. One is trying to figure out what the user meant, and the other is trying to decide what it is we should do in response to that. Now, in terms of figuring out what people meant, by far, I think, one of the biggest advances that have helped conversational agents or conversational interfaces in the last few years is distributional semantics, or you might just refer to them as word embeddings or sentence embeddings. So these are very much a technology from deep learning and the deep learning end of natural language processing. And what they do, if you're not already familiar with them, what they do is they take an utterance that the user said and they give us a representation of that utterance that's basically a vector of numbers. So if you're completely new to this, the easiest thing to do is to imagine that your utterance is mapped into some point in a room. And two utterances that have similar meanings have very close positions in the same room, and two utterances that have very different meanings have completely different positionings in the room. Now, so basically we're just mapping them into a space. Now the spaces we deal with, they're much bigger than the 3 dimensions that we normally deal with in life, but it's really useful for us in building conversational intelligence systems, because what we can do is have a basic set of rules that have meanings associated with certain sentences we had in our training corpus. And the nice thing is we can use embeddings to find and to figure out what sentences might be close in meaning to the ones we were exposed to before. And we're still able to make a nice guess at those meanings. So in terms of extracting those meanings, we can do that in TensorFlow. I stepped through some code here. We've got a couple of our examples from the corpus, and TensorFlow, using a pre-trained language embedding model, we'll be able to spit out a nice sequence of numbers that represent those individual utterances. Now, by themselves, they're pretty ugly. They don't tell us anything. But what is useful, and I think is interesting from a technology perspective for us to look at, is what happens when we sort of do a similarity matching between different vectors that represent individual sentences. And so what I've plotted here is basically sort of like a correlation plot of similarities for, I think it was 8 sentences. And so what you can see if you pay attention here, and you can just sort of pay attention to the colors, is this is showing us that sentences with very similar meaning are projected into the same space in language. And as I said, that's very handy for bootstrapping systems because we're able to get the rough gist maybe of what a user said. So we can see that the first 3 cases are maybe all about looking for information on the maximum credit that's available on somebody's Visa card. And we can see that those 3 are judged to be pretty different to everything else. We then see that there's another block of similar sentences I sort of put together there. Something a bit topical on looking for mortgage breaks at the minute. But we'll see that because the language that we build on isn't always up to date, and that's also a challenge for these sorts of systems, and if you're serious about them, it doesn't work out perfectly. So we've got 3 sentences there about mortgage breaks, and we've another one here about looking for a loan for a holiday, and it's basically saying, yeah, that's a similar meaning. So, you know, this sort of methodology doesn't always work out perfectly, and that's why these systems don't work perfectly, and we need to invest some time and energy into building up those training corpora. But of course, that sort of deep learning based approach, language embeddings, are only part of the solution, part of the system, and what's really quite interesting and worth keeping in mind is that we still need a certain amount of good old-fashioned semantic analysis. And what I'm talking about here is picking out the named entities within content. We're talking about just pulling out entities within content. In other words, pulling out the individual words that the user is talking about. And that's particularly relevant if we're going to fill out a form or we need to apply a query to a database. And there's lots of great tools that you can use to do that. So for illustration here, I've used Spacey, which is really quite popular for a demonstration more than anything else in terms of showing how we can take a corpus, extract information from it, how we can take some individual examples and extract key terms, key elements from it. And of course, under the hood, tools like Spacey are doing a lot of good old-fashioned natural language processing for us, and they're able to pull out not just named entities, but other entities. And if you want, or it's a purpose for you, you can pull out parse trees, etc. No problem. Those technologies are still there and need to be used alongside the more deep learning side of distributed feature extraction. So one other thing I wanted to mention was that so far I've talked mainly about semantics and the meaning of what is said by user, but in call centers and in a lot of different domains, it's worth keeping in mind that there's more information we need to extract. And we can look, for example, at sentiment in the user's utterances. And here I'm just illustrating this point with a really simplistic pre-trained sentiment model that you can easily download and make use of there. But the point being that in monitoring the user, and I think this really falls into what was mentioned earlier about getting the human back in the loop, it's really important not just to pay attention to what the user is asking for, but if they're happy, if they're sad in the conversation, and pull in and make judgments about whether the agent should be interjecting at this point or not. So there's many more different tools and technologies we could look at in terms of what comes together in building the conversational agent. As I said, we didn't even look at the topic of how we decide what to say or how to say it. But one of the big challenges over the years has been pulling in those various components. And of course, many enterprise systems exist. Watson from IBM, Amazon have offerings, lots of different enterprise solution providers have offerings. So too do edge tiers, so too do other providers at different layers of the enterprise hierarchy. But there are some tools, if you're interested in the area, where you can pull together many of these technologies and build your own systems, just even to play around with and to try to get to understand. One that's really useful is Rasa. So Rasa is an open source toolkit for building dialogue or conversational intelligence engines. I'm not saying it's the tool that companies should just go out and use and that's all you need. It's not, because a lot of the costs, a lot of the skills are in putting these tools to work rather than anything else. But Rasa is quite nice. It's all built in Python and pulls together a lot of those different techniques that I just managed. And because it's pulling together so many different tools and techniques, an awful lot of your actual interaction with it is doing things like setting up the workflow. What tools are we going to use? If we're working in English, an awful lot of the tools already exist. But if we're working in a low resource language, we may need to go off and build our own tools, build our own technologies based on templates that exist, but provide a little bit of intelligence into the flow ourselves. Now, I'm conscious of the time and that this is going on a little bit. The one thing I did want to emphasize, though, is the importance of the training data in this sort of scenario, that we need training. And what these systems are doing is not necessarily just taking highly scripted dialogues that are engineered to look perfect, but instead they should be built on dialogue that's being annotated, etc. So Rasa, for example, it's designed to do that. It means we need to provide it a lot of information. We need to do a lot of annotations on the dialogue. And they can take a little while to do. And what we're really looking for example, would be filling in information on the styles of stories that we're interested in, how that is, what is a normal conversational flow through a dialogue. What is it that users can say? What can we annotate in what the users say? So for example, up here at the top, we might have a number of different utterances that users could use for checking how much they spent last week, what their credit card limit is, etc. And we need that data. We need it annotated, because no matter how much a system is engineered, it's going to need a lot of training data to pull things together. The nice idea, though, is once we have that data and we can annotate it, we can build engines. And here, just for demonstration purposes, I showed that we can actually, even within a nice Jupyter notebook, take a lot of the data files we've put together and build up complete systems for interaction. One thing I just wanted to note, because I'm looking at the time, rather than looking specifically at those examples, I wanted just to highlight that for anyone who's interested in this, I don't want to make it sound like I'm just interested in peddling RASA, things like IBM Watson. I won't say it's easy to get started with, but you can at least play around with it to figure out how these systems work. They're important tools that I think people need to work with. But generally, while Watson and tools like it, they're enterprise supported, they're great, people want to sell you the tool, that's fine. I do think something like RASA is quite nice to get started, put the embeddings to work, put the entity extraction to work, and move a little bit forward with the systems. I'm going to leave it at that, Brian, just due to the time there, and hand back.
Yeah, no, that's brilliant. I think at the end, I know when I saw this demo before, there is a box we can type in a message to. So at some point we'll have a conversation with your chatbot later on. You brought up a great demo, and you brought up a load of interesting topics about the technologies involved. It might be interesting just to stay on that for a minute while we have this conversation. If people want to type a question into the Q&A box that they'd like to put to the panel, please do. I'll kick things off just talking about technology. So I know Shane, actually, Rob talked about word embeddings. I know I've recommended your blog post on word embeddings to lots of people, lots of times. It's a real nice introduction to that if people are interested. But maybe you could start talking about the kinds of technologies you use at EdgeTier. Do you mostly build your own? Do you build on top of other things? What's that?
So a mix of both, yeah. We've actually used the RASA toolkit a little bit. But what we find is using the external tools, we come up against some blockers there from clients that we work with. So in enterprise clients, there's a lot of data security type arrangements that need to be upheld. And passing, the customer service data to Google or an IBM where they're not sure where the servers are, we need to get data protection and processing agreements in place. And also from general accuracy, we've been able to do better by building our own models. So we've kind of a standard enough machine learning stack. We do it all in Python. The models and stuff that we use will be definitely based on word embeddings. We've moved from what we previously would have used was kind of normal word embeddings that I think my blog post covers, but we've kind of moved a little bit further now into context-aware type word embeddings and sentence embeddings because we found the accuracy of the models has upticked a little bit more. And typically we feed them then into either LSTM or transformer type neural network models built with the Keras and TensorFlow libraries. So a little bit of setup and all of that. There's some great research out there at the moment in the new kind of universal language models that have added even more accuracy. And I think the limitation we usually hit at this point is, and I think Robert kind of touched on it there, is that the accuracy of the models is almost limited by the accuracy of the training set that we get. So we go into a client and we say like, okay, this is gonna be great. We're gonna hit up these topics, and it's a Pareto. You start with the topic with the biggest impact and you move your way down. You might do 10 and that'll cover 60% of your contact. And then you've got to kind of label them. And we've had a really interesting one recently where we were doing this for a Hungarian client. So they're a Hungarian banking client, but they all speak Hungarian. So it was the first time actually that we were building out the machine learning models, but we weren't able to manually label them ourselves because everything was in Hungarian, and our Hungarian is just a little bit rusty at this point. So they had to label them all, and actually explaining the task of labeling and making sure they were accurate became quite a deal, because you're labeling, when you label something as a machine learning practitioner, I think you're taking into account some of the contextual awareness you have of where models will fail and not fail, and how certain queries could be interpreted in 2 different ways. And all that became a big challenge. And we got to the 95, 96% accuracy, but actually when we looked at the data, we were held back from getting to 98 by kind of the label accuracy, essentially. So that becomes the limitation. But the actual modeling techniques that are out there available, they've really come on. And in terms of accuracy has increased, but probably more impactful for us is the number of training samples required to achieve that accuracy has decreased. And that's been a big impact.
Yeah.
So when we started off building these models only 3 or 4 years ago, we would have like looked at these techniques first. We might have needed like 1,000 or 2,000 samples. Whereas now we can achieve the same accuracy with 100 or 150 samples, which has been a massive, people overlook it, I think, but actually the leap in generalization kind of ability of those models has really
and
improved.
Is that from using sort of pre-trained transformer models in the background?
Yeah, a little bit. Yeah. So we started off, you know, our very first efforts as a benchmark were kind of TF, IDF type approaches. So word counts, then into kind of general word embeddings. So non-context aware, then into more context aware word embeddings, and now using some of the larger pre-trained language models from the Google and Facebook corpus. So yeah, we've just seen that the accuracy is still at the 95, 96s, but the training samples required are starting to drop. Yeah. So that's been a bit of a boon. We can get up and running with a client much faster then, you know?
Yeah. Okay, brilliant. And maybe, Frank, I know one of the things that characterizes Woebot is scale. You've got lots of people using it all the time. What kind of tools and technologies do you use?
Yeah, I mean, like a lot of what Shane was saying there sounds familiar. I mean, like to begin with, when we're building the models, just in terms of scale, I mean, it's all really like we put a lot of store into training the models on very specific data sets because of the area we're working in. I mean, like in terms of challenges, like often you might have specific psychological sort of logic that lots of the specialists disagree on. So it's difficult to get, say, 10 data labelers working together to label, maybe 10,000, 20,000 sentences, pieces of text when there's ambiguity there. So that's one of our big challenges. But then in terms of deployment, so we, like at the moment, we're sort of migrating from a TensorFlow to a PyTorch stack. It sits within AWS, containerized in ECS, and yeah, like it's the challenge is just maintaining the uptime. 99.9% kind of that's what we're looking for.
Yeah.
And then of course at the app level, it's well, if your NLP cluster fails, what do? You just need nice fallbacks and that kind of thing.
Yeah.
So yeah, I mean, so there's always ways around it, but that is our, it's ultimately making that user experience as good as possible. And yeah,
I guess don't forget the good proper software engineering.
Exactly. Yeah.
Nice thing to do. That's brilliant. One other question that came in on the chat rather than Q&A, and I see a few questions on the Q&A that we'll get to in a second, and please enter more, was a question about a topic that came up earlier around, how should we present these things? So when we have a conversational agent, should we be very clear that this is a robot essentially, or this is an automated tool, or should it be left ambiguous about whether maybe this is a real person you're talking to? Do any of you have an opinion on that?
Yeah, well, certainly it's something we think about a lot. I mean, in our onboarding for new users, it's explicitly stated that we are a robot, we're not a human, and we will do X, Y, and Z for you. And if your needs go beyond that, here are the resources. And obviously, throughout that process, we are monitoring what's going on, and we're seeing, is there a risk there, just on the basis of the domain we work on. But yeah, we make, and not only within the app, but around the app, in social media, on like, onboarding goes well beyond the app. So whenever the user first comes in contact with the concept of Woebot, if our icon is a robot, and obviously Woebot robot. So yeah, it's a big part of our thinking.
Okay, great. Shane, did you want to add to that?
Yeah, no, I would back that up. I think honesty is the best policy in these situations. From our point of view, setting customer expectations and not having any surprises is clear. We would encourage clients, I suppose, to be very specific in their responses. So if you can respond to a customer, try and automatically respond with a very specific thing. So I think it's you kind of mentioned there in the last comment where you said, like, it comes down to the software engineering. I think for these things to be functional, every intent and thing you detect where customers are trying to achieve something, it kind of has to map to a function call somewhere. And that's kind of what you're doing. You're parsing out all this text and working out all this freely written stuff in a fancy way. But ultimately it comes down to, make booking brackets, name, address, date. And that's where you're trying to get to, just without errors. So we would tend to do that, and then really always give the customer the option to fall back to an agent. So we'll say, like, hi, I'm an automated, this is a response. Here's what I think the answer to your question is. And then do you still need to talk to an agent? But make that very clear, because if you try to fake it and then the illusion falls apart after 5 or 6 turns of the conversation, I think the overall experience is much worse.
Yeah, that's really good. Brilliant. Then we have a couple of questions in here from the audience. We've already just about have time for the answers to these. So one here is from Kagri about when we're talking about the accuracy of the training set. What do we mean by that? So I guess, the question is, are our models limited by the accuracy of the training set? I guess usually we're used to people talking about the accuracy of a model, not the accuracy of a training set. So maybe.
Yeah, and I think I mentioned that in Hungarian set. So what happened there was we were working with a client that then translated our requirements. So he said, like, okay, we're going to do these 6 topics, or it was 8 or something. And then they said, oh, great, we'll get an army of interns to label all these things. Yeah. And like, the interns were, they were given very quick promotions to machine learning specialists and given, 1,000 queries each to classify. Yeah. But in that process of translation, when I say the accuracy of the training set, just labels being labeled incorrectly. And it happens all the time. I mean, a human will probably only label to a percentage accuracy, and that'll be close enough to 95, 96%. And it's kind of unrealistic to expect your machine learning model then to go beyond that. Yeah. Although you could convince yourself with some of the word embeddings that's it's semi-possible, but you'll never massively beat the issues if you have issues in your training data. So there's a bit of rechecking to be done.
Just to add on to that, I mean, lots of the free text entries that we would process, even if you had a human on the other end of the line, just because of the material, they would very likely make mistakes. So yeah. So that's what you're dealing with. I mean, the training data is going to have mistakes in it. So you just have to, be going through it with specialist eyes as well, sampling the data.
Yeah. I think it's worth pointing out that getting the labels correct is incredibly challenging, because people, when they enter queries, they're investing so much context into whatever they're writing. Yeah. They have their history of interaction, and what seems perfectly logical for them to write down and to have a very clear meaning isn't always the case. And yeah, I think it's interesting what Frank said. You can look at an utterance from a user and it's just really difficult to figure out what they meant. And maybe you can only get it if you can look back right across the entire history of interaction. And I think it can be very important. Maybe, I'm not sure if in an industrial setting this can be checked as much, but in an academic setting anyway, we tend to do a lot on inter-annotator agreement, just checking to see whether 2 different labelers come up with the same labels. And
yeah, we have done that. Yeah, and actually, to Kagri's question there, he asked, did you mean given the best model, the accuracy of your model is limited by your training sets actually? And I think he's right there, but he brings up an interesting point that I think it's very easy to get caught in a whirlpool of model fine-tuning, trying to get from 96 to 96.3, whereas we found actually, and I don't know what your experience, Frank and Robert, is like, the most effective way for us to get higher accuracy is go back and relabel and get more labels and check the labels, not fine-tune the 5th layer in our transformer architecture and change to some other. That works to a point, but once you're up in the 90s, it's very, very difficult to glean the extra bit.
Right.
Yeah, no, that's totally our experience. I mean, we're just going through a relabeling at the moment, and just on that point of having other labelers check, we have inter-rater reliability. We'll have 3 individuals label every sample, and we'll only take whether it's depending on the criteria, but we'll probably only take if two match, that kind of thing.
That's brilliant. Well, I think we're coming up on time, so maybe just to finish, I might ask Frank and Shane just to, as a last question of what are you going to do next? What do you think is going to be the most interesting developments in, I guess, the field as a whole, or what you're doing specifically in terms of new features that you're bringing in? So, Frank, we might start with you.
Yeah, sure. I mean, one of our big plans is to get that. Robert mentioned that idea of context. So to bring in, when you make judgments on statements, that you're not just looking at a point in time, but you're looking at not only that conversation, but the whole user profile. So that you can begin to make smart reflections back to the users, so that they're not just stock, everyone who puts in this will get the same response, but that it will be personalized. So that's one of our big goals, technical goals for the coming period.
Brilliant. That sounds fascinating. And Shane, how about Edge Tier?
Yeah, we're looking at some cool stuff. I think a lot of our, so we have a data science team, and a lot of the work at the moment is actually moving more in the direction of unsupervised learning from the data. So whereas a lot of our work to date has been, supervised, when we are dealing with this topic, here is the process flow, and this is what you help the agents with. Some of the stuff we're looking at now, because we have data flowing through our systems, is alerting contact center administrators to variations in customer contact patterns and topics in real time and automatically. So it's almost like turning them and saying, oh, in the last hour, you've had, more than the expected number of queries about website issues. Is there something wrong with your website? And you can show them example queries. So detecting these in real time as there's a flow of conversation going on has proven quite useful, because typically in contact centers, there's quite a long feedback loop between agent A seeing 2 or 3 website issues and agent B, and they might tell their manager, and they might tell their manager, and eventually the website guy goes, oh, the website's broken. So trying to shorten that feedback loop with an unsupervised approach is an area of active interest for us at the moment.
Brilliant. That's fascinating, actually. That's really exciting. And taking advantage of all that data.
Yeah, there's loads of it there, so it's quite good, yeah.
That's brilliant. Great. Well, I guess we're just coming up against time here, so I'd just like to thank Robert, Shane, and Frank. That was a fascinating discussion. I guess we're doing this series of webinars as part of the online Masters Series that we're doing. Rob is going to, if you got a taste for the deep technical dive in this stuff that Rob presented there, Rob is doing the full version of that at the end of June, so in 2 mornings, on Tuesday and Thursday, the 25th of June. And then we have similar webinars and Master Series sessions coming up on, touching nicely, Shane, you segued into semi-supervised learning and unsupervised learning there quite nicely. We're going to talk about that next, and then talking about reinforcement learning. For anybody who's on the webinar, we'll be in touch. We'll be interested in feedback you have on this, and there'll be more information about those upcoming events in that email as well. So please do look out for that. So the last thing is just say thanks a million. Thanks to everybody for attending. If there's any questions we didn't get to, we'll follow up with those afterwards. And again, just thanks to Frank, Shane, and Rob. That was a great discussion, and thanks for taking the time to do it.